Hi guys, good night everybody. Just let me know if you guys can hear me before I start, please. All right, cool. All right, guys. Okay, so this is just some last minute questions here, guys. That I'm gonna work for you guys. Um, let's see. Right, so we know that the paper two is tomorrow, right? You're gonna have 6 questions in that exam paper. Um, so the first question is gonna be worth 25 marks, and we know the other 5 questions will be 15 marks each, right? My suggestion to you guys is to ensure that you start with question one, right? Start with question one first. Question one is typically going to be a graph. It may be a curve, it may be a straight line, right? If it's a straight line, you're going to be asked to find gradient for sure. So don't spend more than half an hour on that first question, please, right? You need to manage your time wisely in that exam, right? So question one, 25 marks, no more than half an hour on that question, right? Now, some students like to do the exam in order. You don't have to do that, right? You could select the questions that you are comfortable with first and do those questions first, right? That is the best approach I can tell you. Make sure that you work with a clear, transparent ruler, right? Not the one from your geometry set. You need a long ruler if you have to draw a straight line graph. Ensure that you work with a calculator for the exam, a working calculator. Make sure you check it tonight, check it in the morning before you go into the exam, right? So make sure and work with a calculator for me, please, right? What else? That's about it with respect to that. All right, so let me just go ahead and start a few questions here, right? So I have a question here, right? Kishon investigated the relationship between image size and object size while studying shadows, right? His results are represented in the table here. So they're talking about some shadows here, right? And we're looking at image size and object size. So if you all remember, when it comes to a shadow, right, you might have an object here, right? Let's say this is an object. And you might have, let's say, a screen here, and your light source is able to project, right? And you're gonna get an image formed on the screen here. So this here represents your image, right? And we have our object across here, right? So we expect the shadow to be larger than the object, right? So they give us some information regarding sizes. And what they said here for 7 marks, plot a graph of image size versus object size, right? Now, when it comes to plotting a graph, guys, you see this word here, versus, right? You might see the word versus, or you might see the word against. The first variable here is always going to be your y variable, and your second variable here is always going to be your x variable. Please don't make a mistake like that in the real exam. There are some students who they go into the exam and they plot the wrong graph, right? They plot the wrong graph. So just make sure, read exactly what they said. The word, the variable that comes before the versus, right? That's your y, and the variable that comes after the word versus is your x. So before you even draw anything, in your mind, you need to understand exactly what you're gonna plot. So in this case, I know that I have to plot y against x. That's what I'm plotting, right? Now it's 7 marks here, and typically they're gonna give us they'll give us a graph paper, and we may have to select a scale in order to do this, right? So here's what I'm gonna do here. I just need to get this across here. Right, so this is my data here, right? Which one is x and which one is y? Right, so the y variable is image. So therefore, this here is your y and this is your x, right? Now, when CXC is marking a question like this, right, there are certain things that they're going to look for, right? There's certain things that they're going to look for. The first thing that they're going to ask you to do is, or the mark that you're going to get has to do with the scale that you selected, right? Now, let's look at the X variables here, right, which is object size. So what to do to select a scale, you're going to look at your smallest value and you're going to look at your largest value. That is going to allow you to select a scale, a suitable scale in order to do this, right? Now let's see what is the best scale that we can use here, right? So we'll start here at 0 here, right? But you want to cater from 0.5 to 3.0. Could you all suggest a scale that I can use in order to maximize my graph paper? I want to go from 0.5 and I want to go, your maximum value is 3.0. Select a scale for me that I could possibly use to maximize use of the graph paper. Alright, while I'm waiting for this, I've seen some people saying, yeah, graph paper is in the paper, right? It is in the exam paper. You don't have to work with any graph paper. That's there, right? Alright, I've seen a set of scales here. Some people saying 1 block to 0.5, 2 cm to 0.5. Remember, when you're selecting a scale, right, what you're trying to do is to maximize use of the graph paper, right? You don't want a tiny scale, right? So let's see what I would probably choose here, right? Let's see the scale I would probably choose here. If I go 1, 2, 3, 4, 5. If I put 1.0 here, 1, 2, 3, 4, 5, 2.0, 1, 2, 3, 4, 5, 3.0, right? Let me double check that. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Right, so this is the scale that I want to use here. And there's a reason why I want to use that scale, right? I want to maximize the use of my graph paper, right? So every 5 units, so every 5 cm, I'm going to represent 1 unit on my graph paper, right? And that making sense to you all, right? I don't want a tiny graph, right? I don't want a tiny graph. Right, so that's equivalent to 1 cm represents 0.2 units, right? Right, now that takes care of my x-axis, right? So what you need to do here, guys, you have to label, you're getting marks for labeling this. So you're gonna put object, right? And you're gonna put cm. Now you don't have to think about this, this is already here. Just go to your table and you'll get that information right here. There's no need to stress over that, it's right there in the table, right? So let's deal with the y-axis now. So on the y-axis now, we're going to have image size. But look at the smallest number that we have here, 2.5, and we're going up to 15, right? Select for me what scale I should use on my y-axis. So on my x-axis, I'm using 5 cm to represent 1.0 cm, right? I want you to select a scale I can use on the y-axis, right? Keep in mind you want to maximize the use, you want to maximize your graph paper. Right, I've seen some people saying 1 cm for 2 units, 1 cm for 0.5, right? the key thing here is never to draw a very tiny graph, right? That's the whole objective here. Never to draw a tiny graph. Now let me see what I can get from this here. 1, 2, 3, 4, 5, 6. Right? So based on the data that I'm working here, I could probably use 1 cm to represent 1 unit, and I could still maximize use of the graph paper. So 1, right? Actually, wait. I don't want to clutter my diagram too much, right? So 2, 4, 6, 8, 10, 12, 14, and 16. Right? That is the scale I'd probably use on my y-axis here. And again, you need to label this. You have to label this. So you're going to put image, right? And you're going to put CM, right? You guys are getting marks for that. So please label your axes, right? You have to label your axes, right? All right, now, so I have everything labeled here, right? They're not going to give you marks for labeling your graph, but if you want to label your graph, what you do, you go back to the actual question, and you see the question says plot a graph of I versus O. So you can put that. You can say graph right of I against, right? You're not getting marks for that, but if you want to label it, go ahead and label it, right? So on my y-axis, 2 cm represents, right, 2.0 cm, right? So once you do that, now it's just a matter of plotting. So the first one I'm going to plot here is this, which is 0.5 against 2.5, right? Now 0.5 against 2.5, right? That is here. Sorry. It's not there. 1, 2. Yeah, 0.5 against 2.5, that's here, right? That's your first point. Now, when you guys plotting points in the exam, these are the only options, right? Either a dot with a circle around it or an X. Those are your options, right? So select one and you run with that, right? This next one here is 1.0 against 5. So 1.0 against 5 is here. Right? Next one is 1.5 against 7.6. So 1.5 against 7.2 for 7.6. That's here. Right? Next one is 2.0 against 10. So 2.0 against 10 is up here. Right? Now, based on the trend, we could already see it's going to be a straight line. 2.5 against 12.6. 2.5 against 12.246, right? So clearly we get a straight line. And the last one is 3.0 against 15, right? So that's going to be here, right? That's this point here, right? So guys, you're getting the bulk of the marks, right, will be for plotting the points, right? That's where they give you most of the marks, for plotting the points accurately, right? Right, so next thing you're doing here, guys, and I normally tell my class, don't do this, right? Don't take that small little ruler from a geometry set. That is not what you want to use for your graph, right? Always take a long, clear, transparent ruler, not even a wooden ruler, right? A long, clear, transparent ruler. That's typically what I advise my students to use, right? So all we're going to do here now, based on the points that we have here, it looks like the graph is going to pass through the origin, right? So this here represents my line of best fit, right? If your points don't all lie on the same straight line, then you're going to have to draw the line in such a way that it balances the points on either side of the line, right? So 7 marks just for drawing this here, right? Everybody cool with this graph? I think this question is from January 2014, I believe, right? I think it's 2014. Right? I know some people might say, oh, it's June 2023, right? No, I don't roll like that. This is not June 2023 at all, right? All right, so that's my graph. That's my graph for that's my graph here for 7 marks, right? 7 marks. Part B now, we want to calculate the gradient of the line. So the gradient G, right? There's a formula, y2 minus y1 over x2 minus x1. If, as a physics student, you don't know this formula by now, well, you're in some serious trouble, right? We need to know this formula in order to find gradient. So here's what I want you all to do. I want you all to look at my graph, and I want you all to calculate the gradient for me. Look at my graph. Use any 2 points that you want, right? And I want you to calculate the gradient of this line here for me. Yeah, I see a lot of people begging for chem, right? I don't know if I'll have time tomorrow, but I'll see. Right? All right, so I've seen a lot of people getting 5 as the answer, right? A lot of people getting 5. I don't know if that's the answer, but let's check, right? Now, here's the thing, right? Whenever you are asked to find the gradient, what you guys need to do, you need to select 2 points on that graph, right? And there's a rule of thumb that we use. Basically, we need to select 2 points that are more, the spacing between them is more than half the length of the line, right? Any 2 points is totally up to you guys, right? Now, I'm going to choose 2 points here, right? Any 2 points. And I normally advise students to choose points that are on the line itself, not points that you plotted. If the points you plotted is on the line, then go ahead, right? But in a scenario like this here, 0.2, 0.4, 0.6. So let's see, I have a point here, right? I need to put what point is that? That point there is 0.2, 0.4, 0.6. That is 0.6, and that is 3, right? So that's 1 point. We could select the next point here. Let's say maybe here, right? Now I just approximating right now, just to show you how to calculate these things. 2.2, 2.4, 2.6. So this point here is 2.6, and that is 13, right? 2.6 against 13, right? So those are my 2 points that I'm going to select. Now, what you guys need to do, right? What CXC looks for in the exam, they look for this, right? Even though you selected the points, you have to take your ruler and you need to draw a triangle, right? So let me just show you what I mean. Right? So what you need to do in the exam, you need to complete a right angle triangle, right? So this is what I'm doing here. Once you select the points, just take your ruler. It's not going to take you long to do this, right? And you're just making a little triangle for them here. That's all it is. Right? So that's the triangle that we're talking about. That's what we're going to use to calculate our gradient, right? So the 2 points that I have here are 0.6 and 3. Right, so we have 0.6 and we have 3, right? And the second point that we had was the second point that we have here was 2.6 and 30, right? 2.6 and 30. right? Now, before you plug anything into that formula there, right, I want you to take your pencil in the exam and I want you to label this. Call this x1, y1, call this x2, y2, right? You can label it however you want, just be consistent. So all I'm going to do now, because I have the numbers there, I'm going to substitute. So 13 minus 3 over 2.6 minus 0.6, right? And in this case here, 13 minus 3 is going to give me 10, right? 10 divided by 2.6 minus 0.6 is 2. So therefore, I'm getting 5 as well, right? So you all got 5 as the answer, right? So that's fine, right? Somebody's asking if you use the data from the table. Do not do that. Do not use the data from the table because some of those points may not lie on that straight line, right? So don't ever take the points from the table. Go straight to the graph, right? Yes, somebody's saying that, right? That the points, yeah, sometimes the points not on the same line, so don't do that, right? Don't do that. Right, so that's your answer there, 5 marks, right? So typically, if they ask us gradient, that's 4 or that's even 5 marks, right? Let's see what else they want us to do here. They said state the physical quantity which the gradient of the graph is associated. What are they talking about here? That gradient we just worked out. What is that? What are they talking about? What physical quantity are they talking about here? Let's see if anybody knows this. Right, so I saw somebody said the correct answer there. Somebody said magnification. That's what it is, right? It is magnification, right? The gradient that we just worked out there is magnification, right? Now, for those of you who reviewed Lenz's law and all of those things, right? Magnification is given by V over U. That's something you all had to learn for your exam tomorrow. Right? Magnification is given by image distance over object distance, right? The graph that we just plotted there would have been image distance, right, against object distance, right? Now, when you're working out gradient of a straight line, what you're doing, you're dividing y, you're taking y and dividing it by x. So that's I over O, which is really your image distance over object distance. So what we just worked out there was the actual magnification. That's what it is, right? So that's part C for 1 mark, right? Sometimes they do that. They ask us what is the physical quantity or what physical quantity is represented by the gradient, right? Now, during the investigation, Kishon talked with his friend Atiba about the term focal length, right? And they asking us what or define focal length, right? Now, focal length could be defined in 2 different ways, right? Because we can have what we call a convex lens and you can also have a divergent lens, right? And if we have to define what is meant by focal length, right, it is going to be slightly different depending on the lens itself, right? But in this case here, the focal length, right, we could say the focal length of a convergent lens is a distance, right? It's a distance we're talking about here between the center of the lens and the focal point. Right? Now, your focal point, another word for the focal point is called a principal focus, right? So you can use either word there, but you're getting 3 marks for this definition here. What is meant by focal length, right? So that's focal length. See what else they want here. With what piece of apparatus in physics is the term focal length associated with? So I don't know if this is a trick question or something, right? But we're talking about a lens, right? They said, what piece of apparatus are we talking about when we're using the word focal length? We're talking about a lens, right? That's the answer there. Now part F now, right? We have a 10 cm tall tablet computer, right? So you have an iPad or some Samsung something, right? It's 10 cm tall and it's placed vertically 20 cm from a plane mirror. Its image was found to be 20 cm. Or image distance was 20 cm. All right, so we're talking about, they said it's a plane mirror, right? So basically we have a mirror here, right? And we have a tablet, right? So an iPad or something, and they said it is placed 20 cm from the mirror, right? So let's say this is the position here, and it's 20 cm in front of the mirror, right? And what else are they telling us here? It's 10 cm tall, so the height of this tablet is vertical here, right? And it's 10 cm tall. Whenever you guys have questions where they are talking about stuff and you're not seeing it in front of you, a diagram is always helpful, right? If you sketch a little diagram, it'll help you understand the question. So this here is only 10 cm tall, right? Now what they want us to work out. Given the data, calculate the height of the image of the computer. So this has to be a joke question, right? Because CXC is giving us 4 marks to work out this. Could you all put on the answer for this for me here? What's the answer for this? Is that a joke question or not? How to be? Anybody know the answer for this? This had to be a joke question. Right? So I've seen a lot of people saying the correct answer. A lot of people telling me the answer is 10. So I don't know what CXC wants here for 4 marks. For me to just write down 10 cm. Right? There's no calculation involved here. Right? When you look in a mirror and you are 10 cm tall, right? Your image is also going to be 10 cm as well. So this here is simply 10 cm. There's no calculation here. So I don't know. This was 3 marks in the exam. What about part 2 as well? 4 marks for this. What do they want here? They want to know the magnification of this image. They told you the image distance is 20 cm as well, right? Yeah, if you all get out any people tomorrow, you'll be jumping for joy, right? So they want to know what is the magnification here, right? What is the magnification, right? This is not my question, it is CXC question, right? All right, so a lot of people tell me the answer is 1, I agree. When you look in a plane mirror, right, your height of your image and the height of the object is the same. So therefore, your magnification is going to be 1, right? It has to be 1. Right? So the magnification here, right, is going to be 1. There's no calculation as well, right? So 4 marks. So they just literally give away about 6 marks here for no reason, right? 6 marks for no reason. Let me just tell you something about the properties of the image in a plane mirror, right? Which is something that could come in your exam. So they could ask you for the properties of the image in a plane mirror, right? 1, the image is laterally inverted, right? And what that means is that when you look at a mirror and you hold up your right hand, it looks as if you're holding up your left hand, right? So that's 1, lateral inversion. The second thing is that the height of the object and the height of the image is the same, right, in a plane mirror. The third one is that the object distance is equal to the image distance, right? And another property is that the image in a plane mirror is virtual, right? So you all have to know what is the difference between a real image and a virtual image, right? So a real image, right, the rays actually pass through it and it can be formed in a screen. The A virtual image, sorry, right, is one where the rays don't actually pass through it, right, and it cannot be formed on a screen. So sometimes it can ask you to differentiate between a real image and a virtual image in the exam, right? So be prepared to answer that, right? Let's see what else we have here, right? So this is, do we have anything else in this question? I think that was the 25 mark question, yes. All right, let's see what's happening here now. I think this is question 2. Figure 1 shows some physical quantities and their units. Draw an arrow from each quantity to its unit, right? So we have physical quantities and we have units here, right? So let's see. Let's start with an easy one here. Force, right? Force has to be measured in newtons, right? So that's our quantity and that's our unit. Displacement is measured in meters, right? So these two will match up here. And moment, the moment of a force is force by perpendicular distance from your fulcrum. So therefore that's Newton multiplied by meter. So this here will line up here, right? So this is an easy question here. All you're doing is matching the physical quantity with the unit, right? Let's see what's happening here now. So we have to complete this table here. It shows 3 forces and a situation in each force acting here, right? So we have a javelin falling in the air, right? What kind of force are they talking about here? What's the answer for this first part? So I know some of you are wondering why am I selecting some of these older papers, right? CSEC is repeating questions in the paper 2 wholesale, right? I've seen it happen in the last few exams, right? So that's something you need to pay attention to, right? Right, somebody saying 2018. Well, to tell you the truth, with my online physics class, we did everything from 2023 go right back to about 2015, right? So I'm not going to do any questions in that in those years there, right? Right, people saying gravitational force. Yep, that's what we're looking for here, right? Gravitational force. So in this here, you could just put the word gravity if you want, or gravitational force, right? Right? The next one here, we have upthrust and we want a situation, right? Now, CSEC brought a question recently with a calculation for upthrust, and some students had no clue how to do the calculation. Whenever you place an object inside a fluid, right, you're going to have your weight acting downwards, right? But because you're in a fluid here, right, what happens is there's an upward force acting on you, and that force is called an upthrust, right? So you've experienced this if you ever went to the beach, right? You're in the beach bathing for like half an hour, right? And as soon as you come out of the water, you feel so heavy, right? And that has to do with the fact that when you're inside the water, there's an upthrust acting on you, so you feel lighter. But as soon as you come out of the water, the upthrust is no longer there, and all you're feeling is the weight of your body, right? So upthrust, a situation, right? You can say a ship in the ocean, right? Because they want to give you a situation here. So a ship in the ocean, right? There are so many different examples you can use here. You can put a log in a river, right? Anything like that. They want a third scenario, right? So they haven't given us a force, they haven't given us a situation, right? One force that we could probably put here is electrostatic. Right, so electrostatic, and you could say between 2 positive charges. Right, so anything along those lines, right? Let's see what else we have in this question here. Okay, so we have a question based on moments here. So Patrick and Patricia right, showed their class a magical balancing act, right? They both sat on one side of a uniform plank, right, 6 meters plank. Patrick sat 1 meter from the pivot, right? Let me read this properly. Right, so Patrick sat 1 meter from the pivot, located 0.5 meters from the center of the plank, and Patricia sat at 0.5 meters from the pivot on the same side as Patrick, right? So figure 1 shows the magical balancing act. X represents the pivot, right? Okay, so both of them are on the same side of this plank here, right? Now, whenever you see the word uniform in the exam question, it means that the weight of the plank is at the center of the plank, right? That is where the weight of the plank is. Now, what they want us to work out. Part 1, label as W the point on the figure 2 where the weight of the plank acts, right? Now, let me read this properly again here. Right, Patrick sat 1 meter from the pivot, right, located, right, so they're telling us that the pivot is located 0.5 meters from the center. So if it's a uniform plank, it means that W, the weight of the plank, is going to act here, right? That's what it means, right? Now let's see what they want us to calculate, right? Chances are they want us to calculate the weight of the plank. So 1 mark just for doing that, right? The second part, calculate the weight of the plank. Now, whenever you have a moments question, right, you have to decide at which point are you taking moments about, and you have to identify all your clockwise and anti-clockwise moments, right? So here's what's happening here. This is my pivot here. So I'm going to take moments about my pivot, right? So I'm going to say taking moments about X, right? So whenever you're doing this, right, once you identify where you're taking the moments from, right, you need to identify what is clockwise and what is anti-clockwise, right? So picture what is happening if I were to rotate about the pivot. In the case of W is going to do this, right? So you can put in these little lines here to try to understand what's happening. The 400 Newton is going to rotate this way, and the 500 Newton is going to rotate this way, right? So this is typically how I analyze a question like this. So we're going to have clockwise moments. So you're going to say total clockwise moments, right, is equal to total anti-clockwise moments. I can't fit the whole way there, but right now, since you've already identified what is clockwise and what is anti-clockwise, so clockwise is anything that rotates in the same direction as a clock. I've had students ask me what is clockwise, what is anti-clockwise. So in this case here, this force here, right, this W is producing a clockwise moment. So you have to take the weight of the plank and multiply by the distance from the pivot, which is 0.5. Right? Now if you look at the diagram, that's the only clockwise moment that you have. In the case of anti-clockwise, you have 2 of them. The first one is going to be 400 multiplied by the distance from the pivot, which is 0.5. So this is 0.5. Plus, we have a second one, which is the 500 Newton. So this is 500 multiplied by 1 meter, right? So therefore we can say 0.5 W is equal to 400 by 0.5 is 200. 200 plus 500 is going to give me 700, right? So therefore W is equal to 700 over 0.5. So 700 divided by half is going to give you 1400 newtons. Is that making sense? Right, so that's my answer for part 2, right? Right, all of these questions are taken from January 2014, right? So if you're trying to find it in the past papers, January 2014, right? If Patrick sat alone on the plank, calculate where he would have to sit in order to maintain his magical balancing act. The pivot remains as before, right? So let's see what's happening here now. So you're going to draw, right? To understand these questions, you need to draw, right? You need to draw. Now the pivot, they said, remains at the same position, right? So that means the pivot is here, right? This here is 0.5, right? The weight here, we already calculated the weight just now. We got 1400, right? Newtons, right? Now they said Patrick now is, what happened to him? Hold on, I just want to see what is the weight of Patrick, right? So Patrick is 500 newtons, right? And so he's the only person on the plank now, right? Patricia is no longer here. So therefore he's going to have to adjust his position in order to balance this thing. So we don't know where the position is. So what we're going to do, right? So you're going to put 500 here, right? And we don't know this distance. We don't know what this is. That's what you're trying to calculate, right? So this one is very easy to work out, right? Again, you're going to have, if you take any pivot as this, you're going to have a clockwise moment here, and you're going to have an anti-clockwise moment here, right? So all you need to do, right, no fancy calculation, just say 500 multiplied by x is equal to 1400 multiplied by 0.5. So 500x, 1400 by 0.5 is 700. So therefore x is 700 over 500. So therefore x is equal to 1.4. Right? So Patrick needs to sit 1.4 meters from the pivot in order to make that happen. Right? So he has to sit 1.4 meters from the plank in order for that to happen. Right? Right, so some people saying they get 1.4, right? Alright, so let's see what else. So we know we can get a question on thermal physics, and that can be anything basically. State the physical property that varies with temperature in each of the following thermometers, right? So you need to know that temperature, right? Temperature is the measure of the degree of hotness of a body, right? And in order to measure this, we have to use a thermometer, right? So if you have to design a thermometer, you need some physical property that is going to vary with temperature. Now, these physical properties could be things like a change in volume, right? Sometimes when you heat something, the volume changes. So change in volume is a property, a physical property, right? We can have change in pressure of a gas. We can have change in resistance of a piece of wire. We can also have the generation of an EMF, right? Like in a thermocouple, right? So you all need to know different physical properties that vary with temperature. Those things can be used to basically make a thermometer, right? Right, so I've seen people saying, okay, right. So people saying the same thing I'm saying basically. So when we're talking about a lab thermometer, so that's the one that you would have used in a lab, right? So the physical property we're talking about here will be change in volume. Right, that's a physical property. The next one here, thermocouple, right? A thermocouple is a device used to measure temperature, right? But it makes use of something called the generation of an EMF, right? If you all don't know what EMF is, the word EMF means electromotive force, and it's a voltage that we're talking about here, right? Right, Tariq is asking, how do we calculate the reaction force at the pivot? All you need to do, Tariq, is you're going to use total upward force equal total downward force. That's what you're going to do there. Right? Total upward force equal total downward forces. Right? Right, so that is a part 1. Right? Let's see what else we have here. Complete table 3, which relates to the use of a thermometer to its design. Right? So to measure body temperature, they're asking us about a design feature. You all know what the design feature is they're talking about here? Right, so some people saying clinical thermometer, right? All right, so here's what's going on here, right? Now you want to measure, once you hear they talk about clinical thermometer, right? One of the key things, design feature in a clinical thermometer is the constriction, right? So if you all remember a clinical thermometer, because they're asking for design feature, they're not asking you for the thermometer, right? So you're talking about the constriction. Right? That is what allows you to read the thermometer, right? So when you put the thermometer under your arm, right, the mercury is going to expand. It expands beyond the constriction, and then there's a break in the constriction, so it allows the doctor or the nurse to read your temperature, and then they flick their wrist, and that moves the mercury back into the bulb, right? So this is what they want. They want the constriction, right? The next one here now, right? Design feature. To measure temperatures lower than minus 40 degrees, right? To measure temperatures lower than minus 40 degrees. What design feature you think they're talking about it? Right, so some people saying alcohol, some people saying mercury, right? So in this case here, guys, remember mercury can be used to measure very like higher temperatures, right? But if you want to go down to minus 40 degrees here, right, we have to use alcohol in this case here, right? We have to use alcohol in this case to get that temperature there, right? And the last one, they said junction of small mass. That's a design feature, right? So the thermometer that they're talking about here, once you see a small junction, you're talking about a thermocouple, right? You're talking about something called a thermocouple. Now, one of the design features of a thermocouple is that it has small electrical junctions, right? And what is the advantage of that? It allows the thermometer to measure rapidly changing temperatures. So the answer that I want here, right, is to measure rapidly changing temperatures. That's what I want, right? Right? So that's the answer that I want there, right? So let's see what else they want here, right? Right, so I see people talking about crash courses, right? So my exam preparation takes place over several months. So my Form 5 class have been preparing for the exam since January. Since January, I have been doing past papers with them, right? This is a revision class. This is not a complete crash course that you all get in here. My crash courses last months, right? See part 1, State Charles Law. So you all need to know all your gas laws for the exam, right? So the first one, Charles Law, is basically this. V over T is equal to a constant. That's Charles' law. Or it could be written as V1 over T1 is equal to V2 over T2. That is Charles' law, right? Then we have our pressure law, which can be written as P on T is equal to a constant. Or I can write this as P1 over T1 is equal to P2 over T2, right? That's your pressure law. And then the last one is Boyle's. PV is equal to a constant. And we can say P1 V1 is equal to P2 V2. These are all the different ways you can see the gas laws, right? So the first one is Charles, that's this. Next one is pressure, and the last one is Boyle's. You all need to know how to state the laws, and you have to be able to know how to actually use the formulas in order to perform a calculation, right? So let's start with Charles' law. So you all need to rattle this off and try to get the marks easily. So the volume of a fixed mass of gas is directly proportional to its absolute temperature, directly proportional absolute temperature provided that the pressure is kept constant. Right? So just like how I've done it here, you all have to be able to do the same thing as well, right? So yeah, so this is what they could ask you in the exam. They can ask you to state Charles' law, they can ask you to state pressure law, they can ask you to state Boyle's law, right? They can also ask you to describe the experiment for each of these laws, right? Any one of these laws can come as a 25-mark question as your question 1, right? And then we have to be able to apply the gas laws, right? One of the key mistakes that students make when they're using the gas laws is that they forget to convert their temperatures into Kelvin. Once we are dealing with the gas laws, you have to convert to Kelvin. If you work your answer in degrees Celsius, you are not going to get it correct, right? So just keep that in mind. Right, so 2 marks for this. Now let's see what we have here now. So in a sealed cylinder, the volume of a gas is recorded as 40 cm cube, right? And the temperature is 30 degrees Celsius. What is the percentage increase in the volume of the gas if the cylinder is heated until the gas temperature reaches 70 degrees? Now, this is an 8-mark question here, right? And some students may think it's pretty simple, right? But here's how we're going to do this. So we have a volume of a gas here in a cylinder. So let's call that V1. That's your initial volume, right? And that is 40 cm cube, right? That's your initial volume. Temperature is 30 degrees, right? So let's put, so temperature, right, is equal to 30 degrees Celsius, right? But one time, what I want you to do one time is to convert that into Kelvin. If you don't convert to Kelvin, you're going to lose marks, right? Because the gas laws are based on Kelvin temperatures. So you're going to say 30 plus 273, right? Because remember, to convert from degrees Celsius to Kelvin, we have to add 273 to it. So this here is going to be 303 Kelvin, right? So that's my initial, let's call that T1. That's your initial temperature, right? Now, what is the percentage increase in the volume? So we don't know what the volume is, right? V2, we don't know what it is, right? Your temperature, your T2, they said it's 70 degrees Celsius, right? But we have to convert that into Kelvin. So that's going to be 70 plus 273, right? So that's going to be 343 Kelvin, right? So this here is 343 Kelvin, right? So you're getting marks for doing that conversion, right? Converting things to Kelvin, right? So you're getting marks for that. Right? Somebody asks something. If you write the formula and you state, yes, you're going to get some marks for that. If you can't remember, that's a good trick actually. If you can't remember the gas laws, write down what the formula is and write down what each of the symbols in the formula mean, right? So if you can't remember, write down the symbols and just say what they are if you can't remember, right? Right, so let's see what we're going to do now. So based on the information here, we know that the formula that I'm going to use here is going to be my Charles' law formula. So V1 over T1 is equal to V2 over T2, right? So what I'm going to do, I'm going to use this in order to work out my final volume first of all. So this is going to be 40. There's no need to convert this. Leave it as cm cube. T1, that has to be in Kelvin. So this is 303 Kelvin, is equal to V2, which I don't know what that is, all over T2, which is 343, right? Now, I know there are some students, I've seen students struggle with simple calculation like this right in front of me, right? All you need to do here, guys, is cross multiply. This by this is equal to this by this, right? So, we're going to write 303 multiplied by V2 is equal to 40 multiplied by 343. So therefore V2 is equal to 40 multiplied by 343 all over 303, and that is going to give me 40 by 343 divided by 303, and I'm getting a volume of about 45.28. Right? Now, there are lots of students who might reach that stage there and think they finish with the question, right? You are not finished with the question. When you're all doing questions in the exam, right? When you're all doing questions in the exam, always go back to what the question is asking us, right? They said they want the percentage increase. You've seen 8 marks here. I don't like questions where they have a big number here and you're not sure what steps they require in that 8-mark question here. So we still have to work out the percentage increase. So percentage increase, right? I saw somebody arguing with me online how to find percentage increase, right? Percentage increase is always final minus initial, right, over your initial, right? This is something that we do in maths if you want to find percentage change, right? It's final minus initial divided by your initial multiplied by 100%, right? So the final volume is 45.28 minus the initial volume, which was 40, right? And you have to divide that by 40 multiplied by 100, and this here is going to give me, that'll be 5.28 divided by 40 multiplied by 100%, and you're going to get 13.2%. So when you're answering questions, always go back to what is being asked, right? You have to go back to see what is being asked. Right, so guys, if you have not done so as yet, please remember to hit like and hit subscribe, right? So hit like, hit subscribe, right? All right, so what we're gonna do here now, let's see. All right, so we have our next question here. I know you all love electricity, right? I know you all love that so much. Let's see what happened in here. With the aid of a diagram, right, describe an experiment that may be used to investigate the relationship between I and potential difference for a filament lamp, and sketch your expected result, right? So your syllabus says that you have to know the IV characteristic of a filament lamp, a resistor at constant temperature, and a semiconductor diode. You all need to know that for the exam, right? So while I'm here, let me just show you what I mean. Right? So first things first, let me show you the apparatus that we use in order to do this experiment, right? So we have a battery here, right? Put in your positive here, put in your negative, right? And we're gonna put a variable resistor. Right, we're gonna stick in an ammeter in the circuit, right? We should probably put a switch. Right, and you want, it's a filament lamp that we're talking about. So you're gonna put the filament lamp here, right? And we also need to put a voltmeter inside the circuit here, right? Just remember, voltmeters are connected in parallel, not series, right? And ammeter is. So you all need to know this particular circuit diagram, right? You need to know this particular circuit diagram, right? So this is the circuit diagram that we're going to use, right? And if you are asked to describe an experiment, draw the diagram. You're going to get a bulk of the mark for the diagram. And you're going to say, set up the apparatus as shown in the diagram, right? And what you're going to tell them, you're going to record I and the corresponding value of V. So you're going to have a table, right? So you start off. You read off the first current and the first voltage value, right? The next thing you're going to do now, you're going to adjust the variable resistor. If you adjust the variable resistor, you're going to get a different current now. So when you change the current, you're going to record the voltage. And you're going to keep adjusting until you get about 6 different values, right? And one of the things that we do sometimes is that we either turn around the battery or you could turn around the component, right? So the IV characteristic for a filament lamp looks like this. Right, so this is I here, this is V, right? I hope you all saw this somewhere already. So it starts a curve here, and it curves on this side as well, right? So this is what the IV characteristic of a filament look like, right? Now, what they can ask you in an exam question like this is why, or explain why this happens here, right? When the temperature of the filament lamp increases, the resistance of the lamp increases. And you guys have to be able to explain why, right? So inside the filament lamp, right, the particles inside the filament lamp, they start to vibrate more as the temperature increases. Because of this vibration here, what it does, it restricts the movement of electrons, and that is why the resistance is increasing, right? So I've seen this as an exam question. They ask them to describe the experiment, they ask them to draw the graph, and they ask them to explain the shape of the graph, right? So keep in mind, the filament lamp, it gets hotter. When it gets hotter, the resistance increases. Why does the resistance increase? The particles inside the filament, it starts to vibrate more, and this vibration restricts the movement of electrons, and that is why your resistance increases, right? So you need to know the graph for a filament lamp. Let me give you the other two that you need as well. So for a resistor at constant temperature, right, what you will get a perfect straight line like this, right? So it's a straight line, and that's what we call an ohmic conductor, right? And the last one that we need to know for the exam is this one here, which is for a semiconductor diode, right? So in the case of the diode, this one is kind of special. The diode turns on around 0.7 volts. It looks like this, but when you turn around the diode, there's no current flowing in the diode, right? So you all need to know this graph, that's a semiconductor diode. You need to know this one here for a resistor at constant temperature. And you need to know this one here for a filament lamp. You need to know that, right? I've seen some of you all saying no logic gates, but guys, logic gates has to be the easiest question if you do get one, right? Logic gates, if you want to learn something quick before tomorrow, learn logic gates, because that's a very easy question if it comes, right? All right, now let me see what else they want here. I think we have a calculation. So this is part A for 6 marks, right? So they wanted you to describe the experiment, right? You'd have to draw a circuit diagram and you have to sketch a graph. Part B now. The power supply for a circuit in figure 4 provides a current of 1 milliamp to the rest of the circuit. Assuming negligible losses in the connecting wires, calculate the potential difference of the supply. Now, some people don't like to do questions like this at all. So let me get the circuit diagram closer, right? One sec. Right, so this is the circuit that we have here, right? And they said that it is providing, right, the circuit provides 1 milliamp, right? Right, so the power supply is providing 1 milliamp, right? So current is going to flow through the positive terminal. So you have 1 milliamp flowing through here, right? And what the question wants, let's go back here. Assuming negligible losses in connecting wires, calculate the required potential difference of the supply, right? Calculate. Right, so you want to calculate V here, right? What is the potential, right, difference of the supply, right? Now, lots of students, as soon as they see a question like that, they feel that they can use V equal to IR to work out every single thing. Yes, you probably can, but you have to know what you're doing, right? In this case here, right, you know what the current, what is the current being supplied in the circuit, right? What we don't know what is this voltage here, right? So what I would do in a question like this, I will find the combined resistance in the entire circuit before I work out that voltage, right? So we have two resistors in parallel, right? We have these two resistors here in parallel, right? So what I will do, I'll work out that combined resistance first. So 1 over RT for resistors in parallel is 1 over R1 plus 1 over R2. So therefore 1 over RT is equal to 1 over, now since you have 3 kilo ohms and 5 kilo ohms, I will just leave it as, I'll just use the numbers as they are. So 1 over 3 plus 1 over 5, right? So 1 over RT is equal to, so that's 1/3 plus 1/5, right? That's 8 over 15. Now this is the first mistake that students make. They leave their answer as 8 over 15, but that's not the answer. RT is going to be 15 over 8, right? You have to invert it. And you're going to get 1.875, right? And that's going to be kilo ohms, right? I didn't convert anything to ohms. I worked in kilo ohms, so I can just write kilo ohms now, right? So that is the combined, that's the combined resistance for those two resistors in parallel, right? Right, I'm just trying to watch some of the questions that you all saying here. Yeah, you could kind of figure out the law, you know, once you know what is being held constant, right? In each of the gas laws, one of those things are being held constant, either pressure, temperature, or volume, one of them, right? All right, let me see what we're doing here now. So we're not finished yet, right? So all I did was worked out, now let me show you something here. Some students, they have trouble seeing these things, right? I'm going to just draw over the circuit a little differently. So this is 2 kilo ohms, right? And that is in parallel with, sorry, in series with these two here, which is the 3 kilo ohm All right, and this is 5 kilo ohms. Right, this is the circuit that we actually have here, right? That's the circuit that we have. It's just that it looks a little different, right? So I'm drawing it in a way that makes sense, right? Right, so this is the circuit here, basically, right? So what we just worked out, we worked out this combined resistance here. So the total resistance in the circuit, so RT for the whole circuit, is going to be the 2 kilo ohms plus the answer we just got, which is 1.875. So that's going to give us 3.875 kilo ohms, right? So that's your combined resistance in the circuit. So now, to get the voltage, right, of the power supply, all you're going to do now, you're going to use V is equal to IR. Now we use it, right? So the current we know was 1 milliamp. Now this is the tricky part here now. You guys need to know what your prefixes mean. So 1 milliamp is 1 by 10 to the minus 3 multiplied by the combined resistance in the circuit, which is 3.875. Kilo is 10 cube, right? So that is going to give me 1 by 10 cube, sorry, 1 by 10 to the minus 3 multiplied by 3.875 by 10 cube, and you're going to get 3.875 volts. Right? So that's your answer there. That's your voltage. Right, some of you asking if it's going to be posted. Yeah, remember this is streaming live, so it'll be there, right? Right, so that's your voltage, right? That's the voltage for part 1, right? Part 2, right? Calculate the current in the 5 kilo ohm resistor, right? Now let's go to the diagram, right? Now, that's the key to some of these questions. You have to look at the diagram itself, right? So we want to work out the current in the 5 kilo ohm resistor, right? So let's have a look here. So that's the current that is flowing through here, right? Now, let's see what we're going to do here now. You know the current flowing through the circuit, right? I draw the current in the wrong direction, sorry. Flowing this way, then it's going to split into 2, right? And then we're going to pass through here, right? And then we're going to come back here. But what we do know is that the current here is 1 milliamp, right? Now, here's how you're going to do this question. What you can do, right? Because this 1 milliamp, it splits at this junction here, but it recombines. So 1 milliamp is actually passing through the 2 kilo ohm resistor, right? So 1 milliamp is passing through the 2 kilo ohm resistor. Now what can I do with that? What I can do, I can find the voltage across the 2 kilo ohm. So V is equal to IR. So the current here is 1 milliamp, which is 1 by 10 to the minus 3, multiplied by the resistance, which is 2 kilo ohm, right? So therefore this is 2 volts, right? So the voltage across here, across this 2 kilo ohm here, is going to be 2 volts, right? Now what can I do with that? Well, if you know that is 2 volts, then you can work out the voltage across the 5 kilo ohm, right? Now, I don't have time to go through all the rules. There are 4 basic rules that we need to know. There are 2 rules for series circuits and 2 rules for parallel circuits that you need to know, right? So if this here is 2 volts, right? Could anybody tell me what's the voltage across the 5 ohm? When you're doing circuit diagram questions, you always use conventional current, right? Positive to negative, right? Only if CSEC asks us to show the direction of the flow of electrons, right? So some people give me the correct answer, right? Right, so some people saying the answer is 1.875. Let's see if that's really true, right? So all you guys need to do here, right? You see, you know the voltage of the power supply. You just worked out this, right? We got 3.875 volts, right? And you have 2 volts across the 2 kilo ohm. So therefore, the voltage across the 5 kilo ohm is simply going to be 3.875 volts minus 2 volts. And you're going to get 1.875 volts. So that's the voltage across the 5 kilo ohms, right? Now, what do we do with that? So you know the voltage across the 5 kilo ohm. So therefore, you can easily work out the current. So the current I is equal to V over R. So this is 1.875 over your resistance, right? The value of the resistance in this case here, let's go back. Right, it's a 5 kilo ohm resistor, right? So let's come back here. So this is gonna be 5 kilo ohm, so that's 5 by 10 cube. So this is gonna be 1.875 divided by 5 by 10 cube. And you're going to get 0.375 milliamps, right? So that's the current that you're getting flowing through that 5 kilo ohm resistor. Right? Some people asking where the 2 volts came from. I use the current flowing through the circuit and I multiply that by the 2 kilo ohm resistor. That's where the 2 volts came from. Right? So let's see what else they want us to calculate in this question here. Right, so we calculated, so 3 marks for that, right? Now they said in the third part, if the 2 kilo ohm resistor, right, burns out, what current flows through, right, the 5 kilo ohm resistor? Well, the thing is, if this burns out here, right, let's assume that it becomes an open circuit, right, if it burns out. Right? If it becomes an open circuit, then the current flowing through the 5 kilo ohm resistor is going to be 0 amps, right? So if a resistor burns out, right, chances are it's going to become an open circuit. If it's an open circuit, then there's no current that's going to flow in the circuit anymore, right? Right, so let's do a next question here. Right, so this one is on radioactivity. For sure, you guys are going to get a question on radioactivity, right? It's the shortest topic in the syllabus, right? It's the last section of the syllabus, but every single exam paper, there is a question on radioactivity of some sort, right? All right, let's see what's happening here. So we have a nucleus of a radioactive isotope, radium-226. It emits an alpha particle. When it decays to a nucleus of radon, which is Rn, write an equation representing this decay. So, simple question. So we have radium, right? 22686, 22686, right? And they said it emits an alpha particle to form radon. So you have Rn, right? Plus an alpha particle, which is going to be He42, right? Right, so radon now. So when you have a question like this, you have to balance your mass numbers. So we have 226 on the left. You have 4 here. So therefore, to make this balance, you need 2, 2, 2. So that's the mass number for radon. Then we need to look at the atomic number on the left-hand side, which is 86. So you already have 2 here. So therefore, this here is going to be 84. Right? So we're getting 3 marks just for writing that equation. The second part here, how many neutrons are there in radon nucleus? Right? I don't know why they're given 2 marks, but what's the answer for that? Right, so let's see what people are saying here. So this part is easy, right? If you want to get how many neutrons, so the number of neutrons is simply a mass number. So we're looking at 226 here, right? So it's going to be 226 minus the atomic number, which is 86, right? So this is 226 minus 86. You're going to get 140. So we expect to find 140 neutrons inside this thing here. So that's part A. Part B now. Explain why an atom is normally neutral and stable. Right? Explain why an atom is normally neutral and stable. 4 marks for this. Right? I know there are some students, they're not sure what CXC wants there. Anybody feel they know the answer for that? Why is an atom, right, normally neutral and stable? Who said circuits removed from the syllabus? Circuits are on the syllabus, guys. Alright, so some people are saying so I am seeing some correct answers in the chat. So there are some people who know their physics here, right? So here's what CXC wants here, right? So 2 things they're asking you here in Smarter. They want to know why is the atom normally neutral and also stability. So some people might probably just answer the first part here, right? But it's 4 marks. So neutral, let me explain why it's neutral. Right? So it's neutral because the number, right, of protons, right, which is a positive charge, is equal to the number of electrons. Right? So that's it. That's why it's neutral, right? The number of protons is equal to the number of electrons. Protons are positively charged, electrons are negatively charged. Now, they want to know why is it stable, right? So some people have the correct answer there in the chat, right? It has to do with the number of neutrons and protons inside the nucleus, right? Now, an atom becomes unstable, right, when there is a difference in the number of neutrons and protons, right? I don't know if you all ever thought about this, right? Inside the nucleus, you have protons. Now, protons are positively charged, right? Now, think about it. We know that like charges repel. So somehow, we have a set of protons inside the nucleus here, and for some odd reason, they're staying together, right? That's what we call the strong nuclear force, right? Now, the thing is, the neutrons help in binding the nucleus together, right? That's what the nucleus does. The neutrons do, right? If you have more neutrons than protons, what happens is that the nucleus becomes unstable, right? That is why if you want to perform nuclear fission, right, what you do, you bombard uranium-235 with a neutron and you make it more unstable, right? So let's see. Let's see what's going on here, right? So here's what we're going to say here, right? So it's stable, right? The ratio or the number of protons is close to the number of neutrons, right? If the number of neutrons starts to get more, significantly more than the number of protons, the nucleus itself becomes unstable, right? Let's see what else we have to do here now. Part C, what are isotopes, right? So this one is straightforward, and some of you all doing chemistry should know this, right? They are atoms of the same element, right, with the same number of protons right, but different number of neutrons. You all need to learn this definition, huh? Right? So that is what an isotope is, right? Now, in part D now, shows the structure of the atom of an element X, right? So we have some atom here. They want us to state the mass number, the atomic number, and the charge on the nucleus. So here's what I want you all to write down for me here. Based on the data here, what is the mass number of this atom here? Look at the data, and I want to know what is the mass number. Alright, so people saying 11. Let's look at the data and see if that's making sense. Alright, mass number. So your mass number is simply what you have inside the nucleus. So you have 5 protons and you have 6 neutrons. So therefore it's 6 plus 5, so it's 11. Yeah, that's the mass number. What is the atomic number now? What is the atomic number? right? So people saying the atomic number is 5. Let's see if that's true, right? Now you always go to what's inside the nucleus, right? So you have 5 protons inside here, so the atomic number has to be 5, right? It has to be 5. The next thing they want here, they want to know the charge on the nucleus. What about that one? What's the charge on this nucleus here? Oh, the charge on the atom, sorry. I may finish around 10, guys, right? So some people saying 0, some people saying -1, right? Right? Yeah, this topic falls under chem as well as physics, guys. You have to know this for physics too, okay, so they want to know the charge on the nucleus of the atom, right? Now, whenever you're given a diagram and you have to understand what's the overall charge, so we have 5 protons, right? You have 5 protons, and protons are positively charged. Then we need to check and see how many electrons we have. We have 1, 2, 3, 4, 5 electrons, right? So we have 5 electrons here, right? And electrons are negatively charged, right? So let's make sure we have 5 protons, we have 5 neutrons. So if the number of positive charges equal to the number of negative charges, then your overall charge is going to be 0. They cancel each other, right? So the answer should be 0. Same number of electrons, same number of protons, right? Right, I see some people asking if this is chemistry. This is physics. This is in your syllabus, right? Right, so that's the answer for that part. The next one here now, they want us to write the symbol for another possible isotope of X, right? They want us to write the symbol for another possible isotope of X, right? So to do this here, guys, all you need to do, right? So this is X, so let's write it like that. Now the atomic number in the isotope, right, should be the same, right? So we just had an atomic number 5, so you need to keep this as 5 here, right? Now you want to get an isotope, so the mass number has to be different. Now if your mass number right now is 11, then you have 2 options. So what I normally tell my students to do, go 1 up or 1 below. So you can put X 12, 5, so you increase the mass number by 1, or you can decrease the mass number by 1, so you can do this. So all of these here are isotopes of element X, right? So just go 1 above and 1 below and you're good to go, right? All right, now I'm going to do a few more questions here, right? None that I have here, but let's say, right? So we're doing a little ray optics here, right? Let's say I have an incident ray, right, on an air glass boundary, and let's say this angle here is 35 degrees, right? That's my angle here, 35 degrees, right? This here represents my normal, right? And I want to calculate, let's say I want to calculate the angle of refraction right, if the refractive index of glass is 1.5, right? So the refractive index of glass is 1.5, and I want to calculate the angle of refraction, right? Now, what they are telling us here in this question is that n is equal to 1.5, right? Now, when a ray enters from air into glass, it's going to bend towards the normal, right? So it's going to do this, right? And the angle that we're looking for is this angle here. That's your angle of refraction, right? Now you all need to know that n is equal to sine I over sine r, right? So 1.5 is equal to sine of 35 degrees, right, over sine r, right? Now at this stage, I've seen students struggle with a simple calculation like this. All you do is write 1.5 over 1 and you cross multiply. That's the easiest way to work this problem, right? So you can write 1.5 multiplied by sine r is equal to sine 35, right? So therefore sine r is equal to sine 35 over 1.5. So therefore sine r is equal to, so using the calculator for this, sine 35 divided by 1.5, and you're going to get 0.382. So therefore r is equal to arcsine 0.382, right? So when I work this out in my calculator, I'm getting about 22.5 degrees. Right? Now, hear this. When you all giving your answers, when it comes to angles, give your answer to 1 decimal place, right? Don't go to 2 decimal places. Give your answer to 1 decimal place, please, right? Right? People are asking about the physics exam. Yeah, I don't deal in that. I don't deal in any leak papers, right? This is just a last minute revision, right? As it says, it didn't say it's a June 2023 paper, right? So don't quote me and say this is, right? This is the paper. I will never be associated with that kind of thing, right? All right, now let's see. Right, so that's one way you can be given a question like this, right? Another way you can be given a question like this, and students generally they tend to get these questions kind of wrong, right? What if, right? What if I had a scenario like this? So let's say instead of the ray is moving from air to glass, right? Right? Let's say it's 30 degrees, right? And you want to figure out, so n, refractive index for glass, again, we're using 1.5, right? And I want to figure out what is the angle of refraction when the ray goes from glass to air, right? So we want to figure out what is this angle here, right? Now, this particular question, right, always poses a challenge to students because they get confused with the calculation, right? They get a little confused with the calculation, right? All right, somebody's asking about the last question. The last question I did there with the sine and the angles, that's usually about 3 marks, right? Right? So here's what you're doing with this question. So to do this question, we have to use something called the principle of reversibility of light, right? Now there are some students who they will write the equation as 1.5 is equal to sine 30 over sine r, and they'll get the wrong angle, right? Now the refractive index of glass is 1.5, and what I want you to remember is this: whenever they quote a refractive index for you, they are talking about moving from air to whatever material it is. So this 1.5 here is from air to glass, right? So what we have to do, you're gonna think of the light, the ray of light moving in the reverse direction. So you're gonna put 1.5 is equal to sine, right? Now I'm gonna call this r here, over sine 30, right? So when I do this now, again I'm gonna cross multiply. So this is gonna be sine r is equal to 1.5 multiplied by sine 30 degrees. So therefore sine r is equal to 0.75. So therefore r is equal to arc sine 0.75. Right? Now this is one of those tricky questions that people generally get wrong in the exam. Huh? So this is about 48.6. Right? So some people actually got it correct. Right? Now there are two other things they can ask you here. Right? There are two other things they can ask you. Now here's what you need to know when a ray of light is moving from glass to air, right? There are three different diagrams that you need to know. So the first one is this, right? So if you have an angle of incidence here that is less than the critical angle, the ray is going to exit into air. So this is air, this is glass, right? The second diagram is this. If your angle of incidence here is equal to your critical angle, what happens is that the ray travels along the boundary here, right? So this is the second scenario where your critical angle is equal to the angle of incidence. If in the exam they ask you to define critical angle, please draw this diagram here for them, right? That will explain what is critical angle. Next thing here, we have a third diagram. If your angle of incidence is greater than your critical angle, the ray stays inside the glass, right? So in this scenario here, your angle of incidence is greater than the critical angle. So this third diagram is what we call total internal reflection. Right? That's total internal reflection. So you need to know these three diagrams for the exam, right? Sometimes they can ask you things like, what are the conditions for total internal reflection, right? There are two conditions. One, you have to be moving from a dense material to a less dense material. So if you're going from glass to air, that's a scenario. And the other thing is that the angle of incidence must be greater than the critical angle, right? That's basically what it is, right? Right? When it comes to waves as well, guys, make sure you all know this formula. If you have a wave traveling from one medium to the next, right, you all need to remember this formula. We can say that sine theta 1 over sine theta 2, right, is equal to lambda 1 over lambda 2, which is also equal to v1 over v2, right? So this is applicable to waves traveling from one medium to the next, right? So if you had a wave here, right? Let's say we have a wave traveling from, let's say, air to glass, right? And let's say the wave did this, right? The wave might have a certain speed in the first medium, so that's V1, right? It'll have a particular wavelength in the first medium, and it'll also have a frequency in the first medium. When it switches into the second medium, the speed changes, the wavelength changes, right? But you have to remember that the frequency does not change, right? The frequency of a wave does not change when it moves from one medium to the next. And also, you need to know that V is equal to F multiplied by lambda. That is what we call our wave equation, right? So you all need to know the wave equation. Right, let me just, there's another formula here, right, that has to do with critical angle that you all need to know, right? So a refractive index is given by 1 over sine c, right? So sometimes they may give you the refractive index and ask you to calculate the refractive index. Sorry, they'll give you the refractive index and ask you to calculate the critical angle. This is the formula that you're going to have to use, right? So waves doesn't have that much formula, but you need to know them, right? Now, if I have a wave right, this is time in milliseconds, right, and this is, let's say, displacement in meters or something like that, right? And I would have asked you, so this is 10, this is 20, this is 30, and let's say this is 48. Could you all tell me what's the period of this wave? I want to know what is the period of this particular wave. V in equation just now is speed, guys, right? That's speed. All right, so a lot of people telling me 20 milliseconds, right? That is absolutely correct. Your period is your distance between one cycle, right? Is one cycle we're talking about. One cycle is one crest and one trough, right? So it's 20 milliseconds, right? Now, if they ask you to convert that into seconds, it's going to be 0.02 seconds, because milli means I have to divide by 1,000, right? So, what is the frequency of this wave here? Alright, so people saying 50 hertz. Let's see if that's correct, right? Now, your frequency is given by the formula 1 over t. Now, the biggest mistake that students make is that they just take 1 and they divide it by 20. You have to remember that in this formula, your time has to be in seconds, right? So it has to be 1 divided by 0.02, So you need to be careful with things like that. So 1 divided by 0.02, you're going to get 50 hertz, right? That's a common mistake that students make. Some students just say 1/20 and they get 0.05. So be careful of that. Alright, let's see. What else did I want to show you here quickly? Let me just do a mechanics question here for you guys. Let's say I have an object here. The object has a mass of, let's say, 2 kilograms, right? And the height here is, let's say, 0.5 meters, right? And I were to ask you, right, several things. I want you all to calculate for me what is the potential energy of this object here, right? We're going to take G as 10 meters per second squared, right? Here's what I want. I want what is the potential energy of this ball here, or this object at this height. What is the potential energy, right? Right, I've seen a lot of people getting 10 as the answer. Let's see if that's really true, right? So you all need to know your potential energy formula, which is simply mgh, right? So the mass of the object here is 2 kilograms multiplied by g, which is 10, multiplied by the height, which is 0.5, right? And this is going to give me 20 by 0.5, and you're going to get 10 joules, right? So that's the potential energy at that particular height here, right? Now, here's what I want from you all. I want you all to calculate for me the velocity of the object just before it hits the ground. What is the velocity of the object just before it hits the ground? So I've seen several people already work it out, right? A lot of people getting the same answer, right? So chances are it might be correct. Let's see. All right, so this question is based on the law of conservation of energy. At the top here, right, the object has potential energy. While the object is falling, that potential energy is being converted into kinetic energy. So just before the object hits the ground, all the potential energy would have been converted into kinetic energy, right? Now the formula for kinetic energy is this, a half mv squared. So you all need to know this. This is form 4 stuff here, right? So your kinetic energy will be 10 joules, right? Now I'm just going to use a half here, 0.5, multiplied by the mass of the object, which is 2, multiplied by v squared, right? So therefore, right, v squared is simply going to be 10 divided by 0.5 multiplied by 2. So v squared is equal to 0.5 by 2 is 1, so v squared is 10. So v is equal to the square root of 10. So v is equal to, right? 3.16. Right? That's your velocity of this object just before hitting the ground, right? Right? Be careful how you're rounding off. Based on my calculator, it's exactly 3.16 to 2 decimal places, right? Right, so that is one there. Let's see. Let's do a simple Archimedes principle question, right? I have an object here, right, just below the surface of water, right? Now, I want to calculate what is the weight of this object, right? Let me give you some numbers here, right? Density of water is 1000 kg per meter cube, right? That's the density of water. Let me put a weight on the object here. Let's say the object is 700 newtons, right? So I've given you the weight of the object, right? The object, let's say the object just below the surface of the water, right? And I want you to calculate, let's make sure I'm giving you all the numbers, right? So G, let's take G as 10. Let's analyze the question, right? Let's analyze the question. So I have an object here, right, just below the surface of the water. So it's kind of floating a little bit, right? Now the weight of the object is 700 newtons. Now, if you are given a question like this in the exam, right, if an object has to float, right, the weight of the object must equal to the upthrust, right? The weight of the object must equal to the upthrust, right? So therefore, without doing any calculation, you know that the upthrust has to be equal to 700 newtons, right? Upthrust has to be equal to 700 newtons. Now, what you could be asked here, right, is to maybe find the mass of the object, right? Or find the volume of the object, sorry, right? Now, in this case here, Archimedes' principle basically says that the upthrust, right, is equal to the weight of the fluid displaced, right? So those of you who never saw this before, this is something that you need to know. Upthrust is equal to the weight of the fluid displaced, right? Now, in this case here, right, if the upthrust is equal to 700 newtons, the weight of the fluid displaced has to be equal to 700 newtons as well, right? Now, if this object has a weight of 700 newtons, the mass of the object, right, has to be equal to 70 kilograms, right? Now, let me just show you something here. Whenever you're doing Archimedes principle questions, right, there are several formulas that you need to keep in mind. Weight is equal to m multiplied by g. That's important. You also may be given things relating to density, which is mass over volume, right? That's something that could be given as well, right? So keep in mind what Archimedes' principle is. Basically, it says that your upthrust is equal to the weight of the fluid displaced. If an object is floating, the upthrust has to be equal to the weight, right? And these two formulas here are two formulas that are very important to solving a question like this, right? Now, I kind of just made up the question there, so I need some more information to give you a little more detail, right? I'm going to just do one more question for you guys related to pressure, right? Let's say I had right. Oh, sorry about the crap of foot on right. One sec. Right. So let's say I had a gas here, right? A gas connected here, right? And I wanted to measure, right, what is the pressure of this gas, right? I want to know what is the pressure of this gas here. Now, if you have a YouTube manometer like this and you want to calculate the pressure of the gas, right? The pressure of the gas is actually equal to, right? So here's what we need. We need to know the difference in height between these two levels here, right? You need to know what is this height here. So the pressure, right? Now, because this is an open-ended tube here, we're going to have atmospheric pressure acting at the top here, right? So the pressure of a gas from a YouTube manometer is going to be atmospheric pressure plus the pressure due to this liquid here, right? This liquid here is more than likely going to be mercury. So it's going to be rho GH, right? So this is how you measure the pressure using a YouTube manometer, right? That's something that you need to know, right? Another formula for pressure, right, is going to be F over A. You all need to know that pressure is measured in pascals, right? F has to be force in newtons, and area in this formula has to be in meters squared, right? So this is pressure, right? So if I take my hand and I rest it on a table, right, I'm exerting a pressure, and I can actually calculate that pressure just by, if I know the force and I know the area, it's going to be force divided by area, right? Another thing here is that we could be asked to find the pressure in a fluid. So for example, you might have the ocean here, right? And you might have somebody at the bottom of the ocean, right? Somebody scuba diving or something like that, right? And you may be asked to find the pressure exerted on this diver. What you will need to know, you'll need to know his depth, right? So because he's underwater, there are two pressures acting on him. We have atmospheric pressure here acting on top, and we also have the pressure of the water being exerted on him as well. So to calculate the pressure exerted on him, it's going to be atmospheric pressure plus the pressure of the water on top of him, which is going to be rho GH, right? So when you have questions involving pressure, you're going to have to analyze and try to figure out which formula you're going to use, right? All right, guys. So this is as much time as I have available, right? Hopefully some of the questions were useful to you guys. Again, read your questions carefully in that exam tomorrow. Always go back to the question that you're trying to work out. There's some people who go into the exam and they're doing a calculation and they're not clear as to what they're trying to work out. Always go back to the beginning of the question, right? Like I said, do question one first. Don't spend more than half an hour on question one, right? Try your best to draw the graph. You know you're going to get a graph. Whether it's a straight line or a curve, draw the graph. You may be asked to find gradient, right? So make sure and do that properly. That's a 25-mark question, but you can get a lot of the marks, right? The remaining questions, do them in any order. Do them in the order in which you can do the questions, right? Make sure you work with a calculator, guys, right? A working calculator. I know some people will come out of the exam and say, God, my calculator wasn't working. Work with a good calculator, guys, right? So I just want to wish everybody good luck in the exam tomorrow, right? Hopefully you get a good paper, right? For those of you who haven't hit like and subscribe, please hit like and subscribe to this channel, right? Good luck, everybody, and I will see you guys tomorrow. I may do something in chem. I'll see if I have the time, right? Take care, everybody. If I get the paper, I probably will.